So what I want to talk about in this lesson is the formation of the elements. So the formation of the elements. So when we look at the periodic table, so how are all of these elements here that make up the periodic table formed? So as we know, we kind of start off with hydrogen. So if we were to take, for example, hydrogen, and if we were to just look at the core of hydrogen, let's say what is hydrogen? So hydrogen is essentially a proton. So imagine we have 1, 2, 3, 4. So these are all positively charged, and they're just 4 protons or 4 hydrogens. So we have 4 of these protons. Now, because they're the same charge, they're not going to want to really kind of come close to each other. You're going to have these, two positive charges are going to repel each other. So imagine this is one positive charge here, and this is another positive charge here. They're going to repel each other. So what we need is we need considerable heat and pressure in order to force these together. And they're the conditions that we get in the sun. So what's going to happen is gravity will start to bring these together, and then they'll get so far and they'll kind of start to rub against each other. And what will happen is heat and pressure will go up. And then what will happen is quantum forces will be able to take effect, and they will be able to overcome this natural repulsion, let's say, that hydrogen atoms would experience for each other. So they start to actually come together. And what's going to happen is you'll get this process where these will all come together, and you'll end up with, so this is hydrogen, you'll actually end up with helium. And helium has 2 positive charges, 2 positive protons, and then it has just 2 neutral, so 2 neutral subatomic particles called neutrons. So I'm just going to put it in here. So we've neutrons, and these positively charged guys are protons. So this here then essentially is a helium atom. So these all come together, and you get what's known as a helium atom. And this process here, where these hydrogens are forced together, the nuclei are forced together, and they stick together like this, and they give off helium. This is known as fusion. And this fusion process gives off a huge amount of energy. So it gives off a huge amount of energy. Now what you'll notice as well is we started off with 4 protons, and we ended up with 2 protons and 2 neutrons. So what actually starts to happen is 2 of the protons actually decay. They undergo radioactive decay, and they give off radiation, so in the form of energy. And what happens then is they change from a proton into a neutron. So this process where we get, let's say, so you have a proton and it changes into a neutron. This process here is what's known as beta decay. Or beta emission. So it's what's known as beta emission. So essentially what happens is the atomic number so you get this change of a proton into a neutron, for example, and then you get the emission of radiation. Now, so that's how we go from, let's say, helium or hydrogen to helium. And this happens within the core of the star, remember. So we're getting hydrogen being fused together, and it's making helium. It's making a helium core. Now what's going to happen then if you take a helium, and let's say if you've got, so let's say we have another 2 of these, so I'll just copy. So imagine I have another one here, I have another one here. So imagine these 3 helium nuclei, they all come together. So what's actually going to happen then is these are going to fuse together, and you're going to get carbon, for example. So you'll have carbon. So carbon, it's the 6th element, so it has 6 protons. So you can see here, so we have, if the 3 of these join together, you're going to have 1, 2, 3, 4, 5, 6. So you have 6 protons, and that's what's known as carbon. And then if we take this carbon, let's say, so these will fuse into this. If we take another helium nuclei and we fuse this with carbon, for example, what's going to happen is you'll end up with oxygen. So you get oxygen. And then this process will continue on until you end up with iron. So you get iron. So you continue kind of getting this fusion process where the nuclei of atoms are being fused together. And this is all happening within the core of a star, for example. So this process will continue on like this. And what will happen then is you'll end up with a star that has an iron core. So imagine then this is your star, and it has a core of iron, and this core of iron is in the middle of the star. Now what happens is, because this process, because the star needs, for example, it needs this fusion process in order to keep it together and stop it exploding. But once you get this core, what happens is you get like an explosion, or what's known as a supernova. So what will happen is this will explode, and all of these elements that have been, all these elements will be contained, let's say, within the inside of the star. When this explodes like this, all of these elements are going to be scattered into the environment, let's say, that the star is in. So imagine this is the environment, and what will happen is this will enrich the environment with all of these different elements that are formed. Now what's really interesting as well is if you have a look at, so let's say if we take one helium atom and we were to measure that helium atom, and then we were to get the weight of 2 nuclei and 2 protons, they won't actually weigh the same. So what will actually happen is the helium atom, so let's say if you were to weigh each of these, so sorry, if you were to weigh 2 nuclei and 2 protons and measure those and compare them to helium, for example, what you'll find is that helium actually weighs less than 2 protons and 2 neutrons on their own. So there's a slight discrepancy between the weight of a formed helium atom and the individual weights, let's say, of the constituents that make up that helium atom, i.e. the 2 neutrons and the 2 protons. And that difference is roughly 0.73%. So what we can actually do then with this is we know this equation, for example, energy E equals mc squared. So this is Einstein's famous equation. So what it's saying is that energy is equal to mass. So with this, what we can see is that this mass here, this difference, let's say the difference in the mass of the helium and the mass of the subsequent components that make up helium, that difference is accounted for in energy. So what actually happens is this mass difference, it gets converted into energy. So, and that's why this can hold true as well. So there's a slight difference in them. So what we find is that as we go through this process, like it's easier to combine the nuclei of these atoms over here, let's say, but as you move across this way, they progressively become harder. And if you were to take two iron atoms and try and fuse these together, it won't actually give out any energy. So there's actually no difference. If you were to take, let's say, the mass of an iron atom and look at the mass of the individual components that make up the iron atom, there's going to be no difference. So what happens is fusion stops, if you like, with iron. So you don't get any more fusion happening. And as a result of that, you get these explosions and you get these elements being released. But so that's if you were to look again, as I was saying, if you were to look at the mass of there's a small mass difference between, let's say, hydrogen atom and then the individual components that make up the hydrogen atom, i.e. the subatomic particles. Now, like a lot of energy can be given off in this process. If we think about, so this this mass here, if we put it into this formula here as m as the mass, but we can see that this constant here, which is c squared, is a massive constant, is a massive number. So this is the speed of light. It's a huge number. Now, if we take this huge number and we multiply it by even a small fraction like this, we're still going to end up with a fairly big energy value. And that's kind of like the process, if you like, that results in the formation of all the elements, all the way up to iron, for example, is this nuclear fusion that happens in the core of stars. And it's also the process that generates light, for example, the light that we can see, the energy that gives us light that's all around us as well. So hopefully this makes sense, and this is the process for the formation of elements and how elements are forged, if you like, inside the core of stars. And that includes all the elements that make up us and that make up everything that's around us here on the Earth as well. They've all, at one point, were generated in the core of a star. So hopefully that makes sense, and thank you for listening.